Hello everyone, welcome into yet another live stream. And today I will start by sipping some caffeine. So, since the last video isn't performing all that well, it's been ages. It really has been ages, right? Since the last video isn't performing all that well, I suppose there's no better time like the present to make another video. So I just already started, I already animated the first half a minute, a bit more than half a minute, the intro. And so today I just thought we could, I don't know, make some models for particles, because that's what we're gonna need. Intro, outro, thumbnail, because it's gonna be all three of them at the same time. Yeah. Can't donate in Japan. Oh no! It's fine. You already donated so much to charity. Actually, finally you have a cap. Finally you have a cap on just losing money. Oh, well, I suppose donating money to charity isn't losing money. But you did donate to me. I count that as losing money. Damn it, I need to switch up my mindset. I'm trying to do YouTube full time. I need to start being more, I don't know, greedy. I don't know what to call it. I need the money. Well, I don't know. It's getting some used to. It's gonna take some getting used to. Hi, the Caleb. Hi, the Caleb. You know how my, you know about how mass curves space time, right? I saw a video by Floated Physics and Dialect. It's mind blowing. I mean, it does curve space time. Relativity, you mean, of course, because there is also quantum gravity, which I think is hilarious because it's. And Remco thinks it's serious, and I think it's hilarious that Remco thinks it's serious, and Remco thinks it's serious, and I think it's hilarious, but you know. Poor Graviton. Listen, there are only two things that are right in this world, and that is making fun of Gravitons and making fun of the French. Also not theory. Every single field of science has the underdog that I'm gonna make fun of. I can derive the formula for the volume of a sphere with a triple integral. Yeah, welcome! I'm assuming the triple integral you're talking about is like if you take a sphere. I'm in Blender, I could just use this sphere, what am I doing? If you have a sphere, I'm assuming that you treat this, since it's symmetric, I'm assuming that you treat this as a function going up, right? So basically, do you need a triple? I think you could do it with a double, actually. Quantum computing, but I think it managed to give satisfaction. That's great, Ashad! That's great! That's great news! Oh, hell yeah! Hold on, you know what? Let me try. I'm not great with maths, so I wanna try to see if I could do it. I mean, I do believe I would do it with a double integral. So first a circle, right? So a circle, if you consider that a function, you would need this. Oh, but then we need the function of the side. So we need to find a function that fits. One for rotation around xy, one for rotation xz, and one for r. That's an impressively advanced way. Okay, I take it back. I don't think I could do it with rotations. That's impressive. That is really impressive. Oh, I need to add the floor. Could the first one stream, but French crowd is calling. It's always the French. It is always the French. That's what I just said. The only two things you can make fun of is the Graviton and the French. And them all. Every single field of science gets one thing, actually, to make fun of. But today is gonna be a fun stream. It is going to be a fun stream because it's gonna be a fun creative stream. That's because we're gonna try to come up with a way. I want to come up with a representation for elementary particles, 17 of them. Higgs boson, yeah, Higgs boson included. Higgs boson is gonna be there. French is a bigger part of some field of science. Yeah, French, I just consider French to be a laughing stock of everything. So no matter what field of science you pick, French, you can make fun of the French. But that's a whole separate thing. Now, we have them divided into quarks, so basically elementary particles that have the color charge, leptons, so elementary particles that don't have the color charge. You can consider them light, especially the neutrinos, which are the most lepton of the lepton. bosons, which are for interactions, and Higgs, which is for mass, which is kind of fun. Alright, Ramid, bye, have a good one. And so today I would like to come up with some sort of way to visualize all of them. For quarks, what's really annoying is that I really don't want to... The color charge is kind of important. I would really like to use color for representation of color. There's another Ash. Oh my goodness, you're right! Who do I shoot? Oh no! Who's the real Ash? Quick, tell me something only real Ash would know. Alright, no. There we go. Elementary. And then quarks, that's what we can start with. It's obviously gonna be a bit silly. He the one with the wrench. I was even questioning, how do I know you're the real one? What if you've just been a fake and you stole the wrench? Guy could be here. Well, hi there, Zima, welcome. Floor. Now, make the floor bigger, because why not? And then we need some sort of nice texture for the floor. Don't mind the background, that's... Actually... I do want to make the background dimmer, and let's saturate it later on. Hue saturation value, we're gonna desaturate it completely, and we're gonna make it dimmer. Like so. Really dim. There we go. I didn't steal it. Was bestowed on my arc. Oh, you did steal, Ashad, you did. You did steal my heart. I don't want to be a one-trick pony and just do a Voronoi every single time. Whenever I try to make like a creative, fun new floor texture, I just get back to the original thing. Can you describe elementary particles with quantum equations? Depends on what you mean by describe. Because the thing that's so confusing about elementary particles and fundamental forces, both of them, is that it's a massive switch from how we normally do science. So for example, if you think about water, we don't really measure, at least in the current times, we don't really measure the properties of water. What we actually do is we measure the properties of the underlying molecules, and then based on the properties of these molecules, we do just like that. My OBS disconnected me because, okay. And so with elementary particles, however, and fundamental forces, they are elementary, which means there is nothing underlying for us to deduce the properties of. And so instead, when we say that when we describe them, it's more like it's difficult to explain. It's more like we come up with justifications for the properties without an underlying reason. Am I making any sense? I don't know if I'm making any sense or if I'm just an old man rambling about stuff. So school more than my teacher. Well, I'm glad I helped. Hi, the TCG too. Welcome. No, I'm not making any sense. Okay, I see. Basically, that's the reason why we need particle accelerators. Is because we can't just come up with a theory on how massive a quark, for example, is. We physically can't. It's impossible for us to come up with a theory on how massive a quark is. Instead, we just have to measure it and keep measuring it. And then more here in my physics class. Well, funny story. This will be the most advanced physics video I've ever made, so maybe something to look forward to. Texture. Point density. What's a point density texture? Never heard this. Uh-oh, that was bad idea. Delete this. Oh, actually call back to the most recent video. I really do use math notes in Blender this way. That really is how I make my animations with math. Just take the distance, subtract it from value to the 8th power, multiply it by 5 and add them together. Okay, so I feel like point density isn't exactly what we're looking for, considering how... Oh, it's because it's been some particles, that makes sense. Texture. I don't want to be a one-trick pony with Voronoi every single time, or brick. Last video, I think it's number 1 from you. Oh, to be honest. What will it be about? Well, this G will be about elementary particles. In fair depth, I would say. I tried going in depth with quarks, I have failed, and it certainly has been a journey, let's just say. Let's just say it certainly has been a journey. You know what, I have another idea. Mickey Ranson, but his voice is actually amazing, not even joking, he has cool personality, so I enjoy watching. I'm glad to hear, because without that, then I'm just a crazy guy ranting about random things. Models, where is it? Oh, it's a D, that's right. Models, and then table. I have quite a few models, quite a couple, just haphazardly thrown together. Table. And fun fact, I use this table file mostly for the floor texture and not for the actual table. Like a normal person would. There we go. Now I can make this a bit smaller. And now we should have a nice floor. Neat. I would say I also learned more here than I knew ever before about more advanced topics than just basic laws. I really am glad, because it takes quite a fair bit of time and effort to make these. Especially with the research for them. So I think... I feel like my number one right now is the 4 Horsemen of the Universe. That's probably my favorite video, because it's a fun topic and the animations were also pretty fun. Sounds like gibberish at first, but then he presents everything that clicks just right. That's so nice. Thank you, everyone. I don't know how to respond, to be honest. I'm just glad to hear my videos. Quit disconnecting. It's important. My goodness. Amateur behavior. Okay. So, anyway, today live stream will be extremely light, as I mentioned. And that's because we'll be doing just simple, fun stuff. We'll be just modeling elementary particles. And you can't model elementary particles because that's not how it works. Which means this is all just going to be one massive make its artistic interpretation of elementary particles. So, up quark. Let's start up quark. I feel like that's a decent starting point. Hi, the dog can explode. Hi, there's about its cable, which will probably be asleep right now, and go to sleep then. I'll stay awake for the stream. I stream literally every day. Hi, the Kim. Make it busy with 2 most popular videos. I think putting equations in your thumbnails is good. That is... You're not wrong. Okay, you're not wrong. There. Oh, my taskbar broke again. Windows. Once again, all of it is just amateur behavior. Complete amateur behavior. You think I should change the thumbnail of the most recent one? To just have an equation? I put equations in the background right here in the corner. They should go in another circle on sun. Put 1 + 1 equals 3 to get more clicks. I don't care for clickbait. I don't care for clickbait. But yeah, okay, there is certainly... Alright, there is certainly some correlation there, I suppose. But there are no equations in... Oh yeah, but they are less popular too. I suppose fair point. Birthday. Oh, that's cool. When Lamb joins in, I'm gonna wish him a happy birthday. Remember Vitas's clickbait video? Yeah, but I don't like clickbait. I don't like it. The entire Veritasium's clickbait video just felt like a massive, like... Okay, it's gonna sound awful, but to me it really felt like just a bit of cope, to be fair. It felt like just Veritasium walking backwards to find a reason to do clickbait. You have to be more greedy. I know, I am gonna just go broke if I don't, but I don't like being greedy. I don't want to be greedy. Let me anime girl, let me go basic curves. You should do something similar. Oh, I see. So you're saying I should put anime girls in my videos. Got it. Message registered. We'll try clickbait with this one, okay? That's because the thumbnail for this video will be just like 17. Hold on. The thumbnail for this video will be just like 17 elementary particles arranged in the same way as Wikipedia. So this way. And then it's gonna be like elementary particles explained, and you know, question mark, red arrows, circle pointing at something, then whatnot. Anime girls do have some connection with Bezier curves. I have no idea what Bezier curves were. Well, basically when you have 2 points, then you can actually 6 points, if I'm not mistaken. If you have 6 points, Bezier curves allow you to draw a curve between them. Either 6 or 3. It's like a smooth curve between them. The complete model of energy particles and extremely small characters, at least what we have so far, so no one can sue you. I mean, no, I mean, that is all the elementary particles we have, like... I just prefer... Hold on. Quark up. How do I make a quark? Let's give it some glass, because why not? And let's give it like a volume. Like a principled volume underneath the surface that's glowing, because that's cool. Glowing is always cool. There we go. Now texture coordinate, and now generated. Now distance, vector math, there we go. Now math subtracted from 1, like so. Then take this, then power, bring it to like 4th power, because why not? Then multiply it by 5 at the very least, and then pop that bad boy into emission strength, then 0.5, 0.5, 0.5, and then lower this a fair bit, increase this, lower this, increase this to like an 8, increase this ever so slightly, and there we go, we got a glowing crystal ball. Simple. Hated French curve. I hate big streamers because they don't read my messages in chat. I mean, there's a lot of messages those big streamers have. Now multiply these two together. Or maybe not noise texture. Oh, that's a splendid idea. I could use Voronoi texture. Oh, I just had a... Oh, genius. I am so clever. I am so unbelievably clever and genius and handsome and funny. And honestly, just a great person as a whole. Like, my goodness. Can you believe just how incredible I truly am? Okay, instead of this, we can just do power, because... it's gonna be a bit better anyway. And then multiply. Oh my goodness. Hold on, remove the thing from the top. Those were all base sentences, exactly. Science. It's all just science. And then lower the size. Oh, that's gonna be perfect. Then times 100. There we go. And then if we pop that bad boy right on top. No, wait. Pop it off for a second, because we want the scale to be even lower. But you'll get what I'm going for, right? Basically like a... There we go. And now metallic can be 0.25. And now we have a quark. That's gonna be a quark. A quark is just gonna be a Voronoi textured one. Two chemists walked into the bar. Chemist 1, I would like some H2O. Chemist 2, I would like water also. Chemist 1 walks out the bar. Frustrated, assassination attempt fails. How do you not have a gazillion subs? Well, I don't know. It's YouTube. It's all in YouTube's hands. What can I say? Don't really have much say in the matter. There we go. And now once we change the color of the glass, we change the color of the quark, which is especially convenient because this will let us give it a color charge. So basically, you know, red, green, blue, and it will be fun to represent it all, like so. Or actually, maybe there should be a better way to represent color charge. Like, what if I... Ah, that's gonna be a difficult one to implement. Mega allows me to convince my friends I am smarter than them. That's a great joke. Now, oh, this is gonna be painful to implement. In fact, what I basically want is I want the edges of a quark to have a color that I would use to represent the type of a quark, like up, down, top, bottom, charm, strange, and then the center to have a different color that's supposed to represent red, green, blue, anti-red, anti-green, anti-blue color charge. The problem there is that we need... I still don't get it. You mean the chemist joke? H2O2 is hydrogen peroxide, which is dangerous, really dangerous. Boy, nothing better than explaining jokes, I suppose. There we go. So let's go with pink for now. And let's say that right here, that's the problem. It's tainting the original color. So what we need is we would need like a texture coordinate. Oh boy, this is going to be really painful to implement. Camera? The thing that's nice about the camera is that we add a new camera, it's always going to be the same when it's pointing at it, which means we want to find the exact combination of values that make up the front of a camera. So we want to find the value of basically this in the middle. That's what we want to find the value of. Which shouldn't be difficult, it should be actually fairly easy. That's because we just have to separate X, Y, Z and then combine X. Actually, we don't even need to combine them. Yeah, we can just plug them in one of the other. So we want Z. Oh yeah, right, it's cameras, doesn't matter. So we want X squared plus Z squared, distance. Oh, we already have distance node, that's right. What we want is distance zero, zero. Yeah, we want distance from 0, 0, and then we want to invert it, subtract it from whatever. There we go. And right here now we have a mask, which disappears the further away we move. That's not great. Oh, it's because the Z. My goodness, that's annoying. Is it because of the Z? It's not gonna lie, that would be quite a pickle. I don't want to say I'm a genius, but I am a genius. Haha. There we go. Oh, I'm so clever. Cool. So now right here, what we basically have... I wasn't joking in that most recent video, really. That really is how I make up my animations, using math. Which means now what we want is we want to mix the color so that we want white to be everywhere. Mix color. Oh, whatever color. We want mixed colors that white would be everywhere. Except in the middle, where it would be red, for example. Okay, and now one last thing, which is power. Or is it power? Color ramp would be easier. A color ramp that we would use to... That's so annoying. Okay, it's fine, it's fine. Put the multiply back on there. Those charts will make it doesn't care about us and is leading us round to ourselves. I just don't really have anything to add. I think gamers want to order also in again. Yeah. Chemistry bit my butt, now I have 3.98. Okay. Power. Because we want it to be more smooth. So bring it like 6th power. And now it's gonna be incredibly smooth. Or bring it to the 8th power. Wait, no, I'm an idiot. That's the opposite. 0.2nd power. Or in other words, a root, as kids these days would call it. No, wait, that's wrong too. 0.1 is gonna be even sharper. That's... yeah, that's sharper. Never mind. 10th power. I take it back. 10th power. And there we go. Now we have a way to control separately the color of the quark and the color of the color charge. As you can see, right here we can control the color charge. Still, that's way too sharp. Damn it! How'd I mess up so badly? Give me this again. How's it look? Oh yeah, it's pure white, that explains it. Almost failed high school due to cameo. Make this past chem. He will make it so. I'm really glad the chemistry video helped them. I will make an organic chemistry video soon too, which should be fun. Why am I so bad at this? It should be so simple. Wait, that's a uniform. am I wrong? That certainly does look uniform. Why is that uniform? That shouldn't be uniform. Oh, backwards. That's right. There we go. Now it's not uniform. Now hyperbolic tangent, I guess. And then add 1. Divide by 2. Except add a little less than 1. Or maybe don't add anything. That's fair. And don't divide either. Actually, if anything, multiply. Because we want it to be perfectly right in the middle. I think the problem is not having enough 2D women in videos. Exactly, that's the problem. Yeah, and right here the negative also shines, which is not what you want. Or maybe it is. It actually has a pretty nice look to it. Let's see. This isn't changing at all in the slightest. Crank that bad boy up to like 1,000 at the very least. Now let's see how it looks. Well, that's garbage. 100? Damn it. What's wrong? Why is it like this? Why is it not working? Am I crazy? Tie the paper. I should make a video on fluorine chemistry, make it as horrifying as possible. I don't know, I'm not a chemist, I don't know fluorine chemistry. I barely know organic. Kind of. Why am I struggling with this so much? It should be simple stuff. We don't want exponent to be like this, though. Now, this doesn't make any sense. There's simply... Why is this white? That don't make much sense to me. Oh boy. I was crazy once. Yeah, they locked me in the room, a YouTube room, and told me to make videos. Ah, it's that twist, okay. Why isn't this working? Doesn't make any sense. Clamp factor? Is that why? What does that mean? No, that's not it. This doesn't make any sense. Does it? No, it does not. Hue saturation value, maybe, and instead we're just gonna do this. Plug this into saturation, plug it into color, and there... Oh, that's how much we need to multiply it for red to appear. That sucks. Although... I need to multiply it by 10,000 for any red to appear. That's never a good sign. Okay, so we want this to be as small as possible. We want this to be as small as possible then. Right, because we want it to be smooth. Uh-oh. 300 power! I'm so glad Blender just lets you do these sort of things. It's so funny. 4th. Okay. Now what do we want? Wait, I can just remap the range, can't I? I can. Oh, we're multiplying it by 10,000. That makes sense. Okay. So what we actually want is 1, 1. And then slowly increase this value to will in turn eventually lead to what? Why is the distance so large? There we go, which will eventually lead to this. Now we square it. It's gonna be a bit more sharp, which is what we want. Now we bring it to 4th power, it's gonna be even more sharp, which is even more what we want. And now if we plug this in, we plug this in right here. There we go. That's good enough-ish, I think. And green should be the furthest. Ah, oh, damn it, it's not. Ah, it sucks. Sucks in a major way, in fact. You should change your name to Made It when you hit 1 million subs. Oh no, once we hit 1 million subs, we're still making it. We're still gonna make it. World War 3 wanted 1 million humans survive. Yeah, but World War 3 hasn't happened yet, has it? Then listen, that's just an incentive. If you don't want me to stop making videos, then you better not let World War 3 happen. Think about it this way, if World War 3 happens, then I'll stop making videos. Right? That's not a good deal. No one would be happy with that deal. There we go. Okay, this is still a 4. This is so awful. Okay, 8th power because it's still not sharp enough. 20th power because it's still not sharp enough. 80th power because it's still not sharp enough. I could just remap it. I should remap it. I should be professional, not doing it with powers. Okay, so 80th, that's quite a high number. Now I think about this. The 80th power. I like that Blender lets you do this sort of thing, but I really shouldn't do it this way. Instead, we have something called map range. That's what it's called. And we want to map it. What even is this number? I'm sorry? Doesn't make any sense. 1 minus the distance, correct? How big is the distance? Okay, so... I don't get it. How big is the distance between... Oh, that's the camera. No, still doesn't make any sense. There we go. Now we have something that appears to be close to from 0 to 1, correct? This is not a 1. We could actually check how much it is exactly by having a greater than and just seeing where the threshold lies. How small is that number? Okay, 0.1. So what we want is we want them to map values from 0 to... Correct? We want to... I don't know exactly what happens to everything below that range though, which is kind of a pickle. Okay, there's a small point right there. Okay, so 0.3 still works. From there to there, we want to map them to from 0 to 1, correct? Okay, sweet. That would explain why the color was so non-existent earlier on. And now, that's better. I don't like how sharp it is though, still. I guess that's something I'll just have to live with. The green will look awful. Actually not bad, okay. It took me how long? 40 minutes. It took me 40 minutes to make this. That's what 40 minutes of work looks like. But there we have it. Top Quark. Top Quark finished. Now, what we'd like to do right now is come up with the colors theme for all the quarks. What I would like to do is I would like to divide between... Is that Blender is more sophisticated Desmos? I mean, you're not... Here's the thing, Paper. Is it really not? Like, look at what I have so far. we take the... Okay, this is a bit more technical, but we take the vector, we separate it into x, y, z, we add 4.57 to it, then we check the distance between the original vector and the other one with z added, then we subtract that value from 4. This is all mathematical operations, even the map range, even though it doesn't seem like it. What time is it to you? 2 AM for me? I don't know, I don't check the time anymore. Savoring Maker's Victory, making a quark. That was... Oh, that reminds me of the good old days, back when, you know, I was creating the universe, and I made the first quark. Whew, those were the good old days. Okay, so what we want now is value and math node. Blue and RGB. There we go, now you get to pick how bright it is. You can do it this way, for example, and make it extremely bright. Then, what we want is we want a way to pick between different shades. Actually, hue saturation value might be even better for this. So, we have 6 quarks. Up, down are the lightest, most common one. Strange, charm, the heavy... Well, actually, strange is the heavy one, and then charm... Top and bottom are extremely heavy. So we'll represent heaviness with... Actually, we could do it with the simplicity of a pattern. So we could just have scaled like 3 for all of them. Okay, that's how we'll represent heaviness. Then the top will be the topness, so positive charge if I'm not mistaken. Will be a bit more redder, and the bottom will be a bit more bluer, which means RGB. Top will have 0.5 added to it, and bottom will have 0.5 added to the other one. So this is up quark, then we're gonna have a down quark. Down quark, which will be the same, except the only difference will be it will be more blue. It does not make a difference. I see. How about 0.75 in the color and 0.75 right here? Why doesn't it make a difference? That's a good question. What video is it going to be? It's going to be about elementary particles. Like quarks, for example. Okay, that's gonna be the up quark. Okay, we're good. It's fine. Doesn't matter. And then the down quark, it's going to be similar. Except this right here will be bluer. That's not all that blue, I couldn't help but notice. I couldn't help but notice that it's not all that blue. Okay, so I guess we do want hue saturation value, then. Whoops. And we're going to have... That's 1/3, no, that's 2/3, that's 5, 6, 7 9s. Oh, I am good at this. Okay. Right here, we're going to want this. There we go. And then... a video may become invalid in the future when they discover deeper elementary particles. Oh, but I will touch on that pseudonym in the video. Don't think I won't. That there are actually 2 ways we can do research into elementary particles. First one's being checking their properties, and the second one being seeing if there is anything more elementary. Scientists aren't delusional. Like, scientists aren't like, oh yeah, we finally discovered elementary particles, and this time they are truly elementary. Scientists aren't delusional. Scientists know damn well that the research could be proven wrong sometimes in the future. But still, we had these elementary particles for quite a while. It's, you know, with current technology, what is it now? 90 years, I think? That's a really long time for no, you know, more elementary particles to be discovered. 90 years, can you believe it? I don't remember 1940s is, I think, when the first... Actually, I don't know. I can check. When was, like, for example, up quark discovered? This one of the first ones. We could actually even go for the electron, I guess. That would be even earlier on in history. Electric force. This one. 1859! So yeah. Scratch that 90. That's how many years? 60 is 40 plus 140. 160. Over 160 years that we knew about the electron. It's not easy, like, the future in which we discover even more elementary particles, that's a couple hundred years. If it is, even. Maybe scientists have become complacent then. Have you seen scientists? Scientists aren't exactly ones to, you know, take things for granted. It's not really common for scientists to be like, oh, well, it's been proven, I guess there is no need to double check. People don't win Nobel Prizes for rediscovering things. People win Nobel Prizes for proving that they are actually false. We know Augustine's fractal with stairs all the way down. Well, that's one of the possibilities. There are actually three possibilities. The circular, the fractal, and the starting one. So you either have elementary particles, or it oscillates all the way down, or it's circular, as in the smallest particle would also be the largest. Oh yeah, right, that's what I was doing. So right here we have U will be 0.6 because you're down, so you will be redder. U will be 0.4 because you're bluer. There we go. Now this one is more red, this one is more blue. They all have some kind of color charge, which for now we're just gonna need to remove. This is only a fun effect of, you know, just us being able to illuminate the charge with the camera. There we go, and just like that we have a top and a bottom up and a down quark, I mean. Then top and bottom won't be all that much difficult. Let me just double check my notes, or rather not my notes, it's be easier to check as on Wikipedia. Charm and then strange top and bottom are the more massive, right? Charm is giga, oh never mind. Yeah, it was strange. Where's the mass? Mega, alright, yeah, so charm, top and bottom are massive. So what we're going to do is we're going to take this, -4, -4, and on y-axis -2, actually -2.5, let's give them some breathing room, and then we're going to move them both to the right by 3, actually 2.5. There we go, and then this won't be up, this will be charm, correct? Up quark has positive charge, and charm also has positive charge, but charm also has higher mass. So this is a bit confusing, but it's fine, I'll manage. This won't be up, this will be charm, like this. Only 11 more to go with elementary particles, or I mean... yeah, 17. I mean, now that we finished the basis of a quark, it'll be extremely simple to create the rest. Elementary fast, then elementary to elementary ones, and we keep discovering bigger celestial bodies and the bigger ones. I see, I probably understand what the Riemann hypothesis means. Ah, wait, Riemann hypothesis. Oh, which one was it? My goodness, I've been so deep in physics. I remember it's a Riemann zeta function, correct? Riemann hypothesis. Is that the one with the Riemann zeta? It is the Riemann zeta function. Look at me, I am so clever. I've been just dipping so much into physics that become a millionaire overnight. Well, you can also just win lottery. Yes, there are a couple of ways to be a millionaire overnight. Doing a video on the Millennium Papers. The problem with videos on the Millennium Papers is that they're not gonna have any answers. There's gonna be questions. That's kind of the whole point. So I don't know. Charm. Positive charge. Wait, no, I'm an idiot. I got it backwards. This should be 0.6. This should be 0.4. Actually, we could do even 35. Have it even more. Actually, no. 0.4. I like it. As we right here, we could also do 6. 7. Oh, I like that a lot. And then this one is charm, which means this one will be 0.7 too, because it has positive charge, positive plus. Non-trivial zeros, yeah, it's a thing. Even answering notation of those questions. I mean, notation isn't as scary as it seems. Hold on. I do believe Riemann zeta actually is a simple function in itself. Riemann zeta function, there we go. Like, it's not a complex function, is it? It's a sum. A pretty simple looking sum. There isn't really much to it, right? Which is the easiest one? I want to start working on it right now. They're not easy problems, Gemma. There is no easiest one. That's kind of the pickle. If you kind of need to solve the problem to know how difficult it is. So there is no easiest one. Hardest way to get in there. That is an unbelievably hard way. Like, they should really up the price on that from $1 million. 10 million at least. $1 million for that. This is ridiculous. In my opinion, it's kind of insulting that the price is so low. But at the same time, I said that they should up a price. Like, it should be us who's upping up the price, right? Because we as a public kind of have the interest in it. Alright, right here, charm, we wanted to have a much higher mass, so let's represent that with a 5. Oh, that's festive. Look at that, yeah, there we go. And then this one will be strange. Strange has negative, correct? Strange does have negative, and then... Oh, I need some sort of way to differentiate between strange and this. How am I to represent a strange quark, actually? That's a good question. It's a bit more unstable, so I guess I could just increase the detail to like 2. And then we have the top, which is positive. Once again, the only difference being it is much... No, wait. I switched charm, that's wrong. Top. The difference that is much more massive. So let's lower the scale to 2. Let's come by everyone. We accept the solution if you accept $0. Down and then bottom. And then bottom, same deal. 3 right here. There we go. Those be our quarks. They kind of look similar, but at the same time, you know, they are quarks. So what not? Whatever. Look pretty sweet. I don't hate it. I don't like it, but I don't hate it either. Now let's move them all one up, and then I'll leave them there. Why not? It took 7 years, but also it went off to research the guy who spent like his whole life trying to figure out, I think. Oh. Now, that's the quarks. And as sweet as they look, it's not the end of story, because then we also have leptins! Everyone's favorite. Now, what's the deal with leptins? The deal with leptins is that they do not have color charge. Which means first we're gonna have the electron, correct? Am I correct? Electron, muon, tau. Alright, sweet. First, electron is gonna be simple. We just remove the whole color charge thing. We don't care for it. Right here, we replace this with a noise texture, because they're a lot more noisy. There we go. Normalized, sweet. 10th power even. Actually, color ramp. We can, we might, we shall, might as well. There we go. Do we have technology to see quarks yet? Well, that's the pickle there, paper. It's difficult to say yet, because to say yet, you have to assume that they're not elementary particles. If they are elementary particles, we will never be able to see them. Simply because what would you use to see them? It's more like we predict them. It's the whole thing with particle accelerators where they basically see like their strong interaction rather than them. It's really fun. 1/3. No, wait. 1/6. There we go. And then we want to up the brightness a fair bit. This ain't really bright. I changed the material of the up quark. Damn it! Why didn't y'all warn me that I was changing the material of the up quark? Okay, at this point it will be easier to just use the down quark right here and rename it to... No, this one will have to be electron. Not 9.7. 0.7. And then U, the same way. There we go. C++, yeah. Actually, maybe even higher. We want it to be really bright. It's leptin after all. There we go. That's our electron. Then we have muon. Then we have tau. Now, if I'm not mistaken, muon and tau are both just like less stable electrons, unless I'm wrong. Haven't gotten that part of the video, but from what I've seen so far... Yeah, greater mass, less stable. Add not theory and z function not 2 non-traction equals not multiplied z. Oh no, not theory. I make fun of not theory all the time. My whole thing. When I'm looking for something to make fun of in math, I just go with the not theory because it's an easy target. Muon. Oh, we already have a muon. I suppose I did just make a new muon thing. No, electron. Muon, this one. Can I somehow delete this? Delete this muon? Oh, there was like one way to do it, but I remember it was extremely annoying. I think right here we need to switch to unused data. Boy, that's not an easy thing to do. Alright, muon, which will be similar, except the only difference is it will be 1/6 plus 1/3 divided by 2. That's 3/9 plus 2/9. There, that's what I was looking for. You don't like no theory? I think it's funny. I think it's extremely... It's like a... mathematics taken to its extreme, isn't it? That you can just model things as knots. Not getting interesting until 3rd year. What do you have in the 3rd year?